James Webb Telescope discovery before the Big Bang will change everything. The Big Bang is a basic concept that is also easily misunderstood. Nobel Laureate and senior project scientist for the James Webb Space Telescope, Dr. John Mather, answers some frequently asked questions concerning the Big Bang and JWST's role in comprehending the universe's early history. What is the Big Bang? Can we see it? If yes, what and how can we see? To know the answers, let's get started. In this video, we are going to discuss about the James Webb Space Telescope revealing the truth about the events that took place during the Big Bang theory. The term Big Bang is a misnomer for the expanding universe we observe. An infinite cosmos appears to be expanding into itself. The moniker, Big Bang, conjures up images of a firecracker going off at a specific time and location, with a center. There is no center to the cosmos. The Big Bang occurred simultaneously everywhere and was a process, not a point in time. We know this because, 1. We see galaxies moving away from each other rather than toward a central point, and 2. We detect the heat left over from the beginning of time, which uniformly fills the universe. We cannot view the Big Bang in its entirety. We can see the heat from around 380,000 years after the cosmos began expanding 13.8 billion years ago, which is what we refer to as the Big Bang. The heat fills the universe and blankets the heavens. It still does, actually. The Cosmic Background Explorer, COBE, the Wilkinson Microwave Anisotropy Probe, WMAP, and Planck satellites, which were created by NASA and ESA, were able to map it. There were just minor temperature waves in the universe at this moment. Although JWST will see farther back than Hubble, COBE, WMAP, and Planck all saw further back than JWST. JWST was built to observe a time of the universe's history that has never been viewed before. Rather than the beginnings of the universe, we hope to view the first objects that created after the Big Bang when the cosmos cooled. That period is hundreds of millions of years later than the one for which COBE, WMAP, and Planck were designed. We believe the temperature ripples they saw were the seeds of galaxies. We have no idea when or how the universe began to form the first stars and galaxies. Looking very far away is the only way to see back to when these items were formed. Hubble isn't big enough or cold enough to detect the feeble heat signatures of these faraway objects. Following the Big Bang, the first generation of stars formed the chemical ingredients that make up life. We're here because of them, and we'd like to know more about how that happened. We have theories and forecasts, but we have no idea. The early stars must have had an impact on our history in some fashion, starting with stirring things up and forming chemical elements other than hydrogen and helium. So if we truly want to understand where our atoms came from and how the little planet Earth became capable of supporting life, we must first measure what occurred at the beginning. Infrared detectors, which could catch the feeble light from those early stars and galaxies more than 13 billion light-years away, were the missing piece of technology. The Hubble Space Telescope was designed to detect visible and ultraviolet light. The wavelength of visible light is stretched into the infrared section of the electromagnetic spectrum by the so-called redshift of these early galaxies due to their distance. Makarian, who is also an interdisciplinary scientist at NASA's James Webb Space Telescope, JWST, scientific working group, said, Hubble had a whole lot of top-line goals, many of which were like 20 years old. Science had progressed and evolved in certain areas by the time they created it. In the 1980s, shortly before Hubble's 1990 debut, astronomers learned that galaxies originated far sooner than predicted. Later, Makarian relocated to the United States to work on the Near-Infrared Camera and Multi-Object Spectrometer, NICMOS, the Hubble Space Telescope's first infrared detector, which was installed during the telescope's second servicing mission in 1997. NICMOS, which consisted of 3 infrared sensors with 256 by 256 pixels each, was Hubble's first step into the infrared universe. It became clear that a large space observatory would be required to reach those early stars and galaxies, which had lit up the universe after hundreds of millions of years of darkness following the Big Bang, when the expanding space was solely filled with hydrogen atoms. The technology needed to observe the mythological first light in the cosmos has not yet been built for this telescope, currently known as the James Webb Space Telescope, formerly called the Next Generation Space Telescope. The telescope's development, which began in 1996, has needed many technological advancements in order for it to leave Earth. The distinctive primary mirror, which is made up of 18 independent pieces that unfold and adjust to shape after launch, is one of these technological achievements. The telescope was so large that scientists had to come up with a novel way to fold it into the rocket fairing. The beryllium mirrors are extremely light. Webb's most notable feature is a 5-layer sun shield the size of a tennis court that reflects more than 1,000,000 times the heat from the sun. The telescope's 4 components, cameras and spectrometers, are said to have detectors capable of reading extremely low signals, according to NASA. One of the instruments, the NIR spec, features programmable micro-shutters that allow up to 100 objects to be observed at the same time. A cryocooler on the telescope keeps the mid-infrared detectors at -266 degrees Celsius. With its separation from the Ariane 5 complete, the giant telescope now stands alone in space. All eyes are now on the first image it shoots back to Earth in the next 6 months, which will herald in a new era in astronomy and forever change our understanding of the universe. The telescope will go through a 6-month commissioning procedure once it reaches its designated orbit by the end of January. During Webb's month-long, million-mile voyage to operational orbit, the unfolding process will begin. Before we can safely run the research instruments at -228 degrees Celsius, the observatory will progressively cool down to its cryogenic operational temperatures. The telescope was developed by scientists and engineers from 14 countries and took 40 million hours to complete before it could be mounted on top of the rocket. The telescope is so sensitive that it could possibly detect heat from a bumblebee flying at the same distance from Earth as the Moon. The telescope, which will be the world's most advanced observatory for the next decade, will study every phase of our universe's history, from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth, as well as the evolution of other planetary systems in the universe. The successful launch of the James Webb Space Telescope marks a huge leap in the field of observational astronomy, opening up the ultimate frontier of the cosmos, stated University College London's Dr. Ayush Saxena, who has secured working hours with the telescope. "I can't wait to discover what the telescope reveals about the most distant galaxies in the cosmos, as well as possibly habitable planets," said Ayush, an astronomer attempting to understand the birth and evolution of stars and supermassive black holes. The James Webb Telescope, regarded as a game-changer in astronomy, will shed light on the mysterious sorts of planets that are larger than Earth, smaller than Neptune, and orbit their stars closer than Mercury orbits the Sun. The telescope will stare back over 13.5 billion years as a powerful time machine with infrared vision, allowing scientists to compare the faintest, earliest galaxies to today's magnificent spirals and ellipticals, revealing light on the evolution process. While exploring the intriguing atmospheres of extrasolar planets, it will be able to look straight through and into vast clouds of dust that are opaque to visible light telescopes like Hubble, and potentially even locate the building elements of life elsewhere in the cosmos. Will the James Webb Telescope unveil the secrets of Big Bang? Will the birth of Earth be known with the help of James Webb Space Telescope? Will James Webb Space Telescope create a revolution in the theory of Big Bang? To know more, please subscribe and get notified about the latest updates. Look forward to seeing you in the next one. Until then, peace.